Welcome to the Shifted Ledger, the podcast where we break down complex topics.
Glad to be here.
Yeah, so today we are doing an episode titled The Code in the Courtroom, Navigating Industrial AI Compliance. And, to start, I really want you, the listener, to picture this ultimate tech utopian dream.
Oh, the famous lights out factory.
Exactly, the lights out factory. It's this vision that the global manufacturing industry has been, just pouring billions of dollars into for decades now.
Right. It's the absolute pinnacle of Industry 4.0.
Yeah. So picture this massive, sprawling facility, right? Like 1 million square feet out in the Nevada desert or somewhere outside Shenzhen. But inside, it is pitch black.
Because there's no humans.
Right. The lights are off. The climate control is dialed way back because, machines don't sweat. Break rooms are totally empty. It's just a flawless symphony of AI, IoT sensors, and robots working 24/7.
No sick days, no shift changes, just math.
It's exactly. Mathematically optimized efficiency. But our mission today is to ask a really critical question, which is, what actually happens when that pristine dream hits the chaotic, messy reality of the physical world?
Well, it hits a wall. Hard. And that collision is happening right now across the global manufacturing sector.
Right. And to explain exactly why factory managers in the industry really must not rely solely on artificial intelligence without proper human oversight, we brought some fascinating sources today.
Yeah, we have a really great stack of materials. We're pulling from academic papers on predictive maintenance, real-world incident databases, the evolving ISO safety standards for 2026.
Which are changing everything, by the way.
Completely rewriting the landscape.
Well,
We're also looking at postmortems of huge automation failures, plus a CDC fatality report from way back in 1984.
1984, wow.
Yeah, it just proves how long these underlying human-machine tensions have been bubbling,
Totally. So let's dig into that lights out mirage first, because on paper, if you're a CEO looking at a spreadsheet, it sounds irresistible.
Oh, the economics are staggering. We're talking about 35% labor cost savings.
Which is huge in manufacturing.
Right. And a projected 30% reduction in machine downtime because the predictive algorithms catch things before they break.
So 35% cheaper and 30% more uptime. You can see why they bet the farm on it.
You definitely can. But this is where we have to talk about a concept from cognitive engineering called the ironies of automation.
Okay, what is that?
So it's a paradox outlined by a researcher named Luzanne Bainbridge back in 1983.
So she was looking at, early digital control rooms.
Exactly, like nuclear power plants during the 3 Mile Island era. But her theory applies flawlessly to modern AI. The paradox is that the more advanced and reliable an automated system gets, the more crucial the human operator becomes.
Wait, really? You'd think it's the opposite. If the machine does everything, the human just sits back?
Right, that's the trap. A highly advanced algorithm handles all the routine, predictable stuff perfectly. But that means the only anomalies that actually filter through to the human are the most complex, the most ambiguous, high-risk edge cases that the programmers never saw coming.
Oh, wow. So the AI just filters out the easy stuff and drops the absolute worst nightmares right into your lap.
Exactly. And the irony is, because the system works flawlessly for months, the human operator isn't actively practicing their skills.
They're just watching screens.
Right. They lose their physical intuition. So when the machine suddenly encounters something weird and just throws its hands up and faults out, it hands manual control back to a human who is totally out of practice, and they have seconds to react.
That totally reminds me of flying a commercial jet on autopilot.
Oh, that's a perfect analogy.
Yeah, the computer's great for cruising, right? It manages the fuel, keeps the plane level, handles the crosswinds. You barely feel a thing.
It does the routine stuff flawlessly.
But if a sudden storm hits, or a pitted tube freezes and the sensors go crazy, the autopilot just disengages. And if that pilot's just been staring at a screen for 5 years, they're in trouble.
Yeah.
You desperately need a human pilot with physical intuition to grab the yoke and just feel the aerodynamic stall.
Yes. You need someone who can feel the airplane. And that translates perfectly to a modern assembly line. Think about AI hallucinations.
Right. We hear about language models hallucinating, but how does an assembly line hallucinate?
Well, say you have an AI vision system inspecting metal parts on a conveyor belt. It's trained on millions of images of perfect parts.
Right.
But the real world is messy. What if a new batch of raw material has slightly different chemical properties? Like maybe it's got a slightly higher oil content.
So it looks a bit shinier under the factory lights.
Exactly. The unsupervised AI has no physical intuition. It doesn't know the supplier changed the oil mixture. So it might hallucinate and reject thousands of perfect parts, or worse, approve thousands of defective ones just because the visual signature matched its narrow training data.
But a human would catch that immediately.
Right. A human walks over, feels the material, goes, oh, this feels waxy today, and adjusts the machine. The human catches the physical nuance the AI is blind to.
Which brings us perfectly to what happens when a massive company just ignores this paradox completely.
Yes, the ultimate case study in hubris.
Tesla's production hell.
Oh, man. The Model 3 ramp in 2017 and 2018, it's a masterclass in the dangers of hyperautomation.
So set the stage for us. What were they trying to do?
They were trying to build a mass-market EV, a $35,000 baseline car, decent range, but the kicker was the target. 5,000 cars a week.
5,000 a week is an insane cadence.
And to do it, they completely discarded the traditional manufacturing playbook. They decided to skip beta production testing to save time.
Wait, they skipped the beta test. Isn't that where you build the soft prototypes to figure out if the robots are going to crash into each other?
Exactly. Traditional automakers spend months doing that. Tesla skipped it, relying entirely on digital simulations. And they went for extreme vertical integration, trying to make almost everything in-house, even the battery packs.
And Elon Musk called the Fremont factory the alien dreadnought, right?
Yes, the alien dreadnought. The goal was a facility so advanced it wouldn't even look human. 95% automated, thousands of robots, crazy conveyor belts everywhere.
I read they even had something called flufferbots.
Yeah, flufferbots. They were these highly complex robotic arms programmed to pick up pieces of fiberglass fluff and place them on battery packs for sound dampening.
But picking up loose fiberglass fluff with a rigid metal pincer sounds like a nightmare. A human hand can do that in half a second.
Exactly. It completely ignored the fact that humans are just better at tactile, flexible tasks. So when they flipped the switch on this alien dreadnought,
Let me guess. It completely crashed.
it was a cascading failure. The system gridlocked. They were falling 500 cars a week short of their goals. Robots were misaligned. Conveyor belts were dropping parts.
Ouch.
They had a $743 million net loss in Q2 of 2018.
Almost $1 billion. And this is when Musk was literally sleeping on the factory floor, right?
Yep, manually untangling the automated lines.
Yeah.
He eventually had to admit it publicly. He tweeted, yes, excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated.
Humans are underrated. That's quite the concession from him.
It really is. And, the traditional guys in Japan using the Toyota production system were watching this happen and just shaking their heads.
Because the Japanese style is, get the process perfect first, then bring in the robots.
Precisely. If you prematurely hyper-automate a flawed physical process, you don't solve the problem. You just scale the waste. You make the wrong thing happen at superhuman speed.
Okay, I hear that, but let me push back a little here. Wasn't Tesla's extreme ambition kind of necessary? I mean, the legacy auto industry was completely stagnant on EVs. Sometimes you just have to break things to innovate, don't you?
I mean, from a market disruption standpoint, sure, it forced the industry's hand. But operationally, the financial and physical bleeding was totally unsustainable. They literally had to tear out multi-million-dollar conveyor belts and build massive tents in the parking lot just to put humans back on the line and manually build the cars to survive.
Wow. So they were forced to pivot back to human-led assembly.
Yeah, because the machine just couldn't handle the physical variability of the real world.
That's fascinating. But, Tesla's failure was highly visible, like everyone saw it. But relying too heavily on AI can cause these invisible, insidious failures on a factory floor, right? Long before the line actually shuts down.
Right, which brings us to the silent threat of model drift and data poisoning.
So AI models rely entirely on data from IoT sensors, right?
Yep, they don't have eyes or ears, they just read voltage from sensors.
Right.
And the factory floor is a brutal environment for sensors. Extreme heat, vibrations, chemicals. The data shows that 30 to 40% of industrial sensor data requires significant cleaning before it can even be used.
30 to 40%. That's a massive failure rate.
It is. And the dangerous part is how they fail. They rarely just snap and turn off.
Right. If a sensor dies, an alarm goes off and you fix it.
Exactly. What actually happens is they slowly degrade. A temperature sensor slowly loses its calibration over months. We call it measurement drift.
And traditional safety alarms miss this drift
Yeah.
because they just look for a rigid mathematical limit.
Right. Say a machine is safe up to 110 degrees. The degraded sensor might slowly drift from reading 100 degrees to 102 to 104. It's technically under the limit, so no alarm goes off.
But in reality, the machine might be running at 120 degrees and melting itself.
Exactly.
It's like driving a car where your windshield is slowly getting covered in mud,
Yeah.
but you're just staring at your GPS, and the GPS insists the road is perfectly clear. If you only look at the screen, you are absolutely going to crash.
That's exactly it. The AI is driving blind. It experiences silent drift, making physical adjustments based on a totally false reality. It could ruin thousands of parts or destroy a machine, and it thinks it's doing a great job.
So how does Industry 5.0, this human-machine synergy, fix that?
Humans bridge the data trust gap. A human can walk by that machine, feel the ambient heat radiating off the metal, or smell burning hydraulic fluid, and instantly know the sensor is lying.
Humans have physical context,
Right. We validate the anomalies that the machine is entirely blind to.
which is so crucial because when an AI-driven machine makes a decision based on faulty data, or if a human unexpectedly steps in its way, we aren't just talking about broken products anymore.
No, we're talking about life and death, the physical stakes.
Yeah, let's get into that, because manufacturing is inherently dangerous. OSHA has their Focus 4 hazards, right? Falls, struck by, caught in or between, and electrocutions.
And for decades, the robotics pitch was, hey, robots remove humans from these dangerous jobs.
Right, the dull, dirty, and dangerous work.
But the reality is much darker. When you look at the CFOI data, the census of fatal occupational injuries, there were 41 robot-related fatalities between 1992 and 2017.
41 fatalities. That is grim.
And 77 severe injuries just between 2015 and 2022. Amputations, crushing injuries.
Which takes us back to that 1984 CDC report you mentioned earlier. Walk us through that, because it's a perfect example.
It really is. So this was a 34-year-old die-cast operator, extremely experienced, 15 years on the job.
So he knew what he was doing.
Exactly. He was working with a massive hydraulic robot arm. The automated system jammed, and the operator, probably feeling pressure to keep the line moving, bypassed the safety interlocks and stepped into the robot's work envelope to fix it quickly.
Because he thought he could beat the machine.
Right. But while he was in there, the robot cleared its own fault, automatically restarted, and the arm swung around and pinned him against a steel safety pole.
Oh, man.
Yeah. He died in the hospital a few days later.
And the tragic part is, he wasn't goofing off. He was just trying to do his job efficiently.
That's the pattern. These accidents are almost always experienced workers who underestimate the machine's lack of situational awareness. The robot doesn't know you're there, it just executes its code.
And this isn't just a 1980s problem. Look at the 2025 Tesla Optimus incident.
Right, just last year. A worker at Fremont was knocked unconscious and pinned by the Optimus robot's arm.
And the craziest part to me is that it happened during a maintenance window. If you're doing maintenance, shouldn't the power be totally cut?
Well, that exposes a huge issue. Unexpected activation causes about 60% of all robot accidents. But when you are dealing with a dynamically stable humanoid robot like Optimus, standard lockout-tagout procedures LOTO create a physical paradox.
Explain that. Because normal LOTO is, you kill the power, you put a physical padlock on the switch, and you keep the key.
Right, the machine is dead and safe. But a walking robot balances using electric servos firing thousands of times a second. If you de-energize a walking robot, it just collapses to the concrete.
It falls over.
Yeah. It's a 200-pound dead weight. You can't ergonomically maintain a robot lying flat on the floor.
So you have to leave it powered on so it stands up.
Exactly. But if it's powered up, it's calculating balance. A single software glitch. And the arm could suddenly articulate to maintain its center of gravity, crushing the mechanic. It demands entirely new LOTO procedures that most factories just don't have yet.
Okay, so let me ask you this. If cobots, collaborative robots, are designed specifically from the ground up to work right next to humans without safety cages, how are people still getting hurt by them?
That's a great question, and it's a huge misconception. Cobots can actually increase hazards if not deployed perfectly.
Wait, how does a safe robot increase hazards?
Because the hardware is safe-like, if the arm hits you, a force sensor stops it. But what about the tooling? What if you program that cobot to hold a razor-sharp pneumatic cutter or a high-temperature welding torch?
Oh, right. The joints might stop, but it's still swinging a blade at your face.
Exactly. Software errors or unexpected human movements can turn a certified safe cobot into a lethal hazard instantly.
Which means regulators are not just sitting by anymore. They can't treat these things as just smart tools.
No, they are not. The entire legal framework is shifting right now in 2026.
Let's get into this regulatory minefield, because connected robots mean connected risk, right?
Exactly. The global standard for robot safety, ISO 10218, just got updated for 2025-2026. The safety section grew from 28 pages to 50 pages.
That is a lot of new rules.
It is. But the most crucial shift is that certification moved from the hardware to the application.
So you can't just buy a robot with a safe sticker on it anymore.
Nope. You have to assess the entire workspace layout, the tooling, the lighting, the human foot traffic. If you put a certified safe robot in a dangerous layout, your certification is void.
Wow. And they're writing a new standard specifically for walking robots too, right?
Yeah, ISO 257851, because traditional rules don't work for machines that walk. Which brings up a massive compliance mistake factors are making right now, treating humanoids like wheeled AGVs.
Automated guided vehicles. The little carts that just follow a magnetic strip on the floor.
Right, AGVs are predictable. They follow a fixed path. But humanoids navigate dynamically using AI vision. They can step over obstacles or change routes on the fly.
So if you just paint a yellow line on the floor and tell workers the robot stays there,
You're creating a massive liability because the humanoid will absolutely step over that line eventually. You have to account for dynamic fall zones and unpredictable routes.
and how is the law handling this? I saw something in the notes about the learned hand formula.
Yes, it's an old tort law concept for negligence. B is less than P times L.
Okay, you're going to have to break down that math for me.
Sure. B is the burden of taking safety precautions. P is the probability of an accident. And L is the gravity of the loss. So if the burden of hiring a human supervisor, B, is less than the probability of the AI hallucinating P multiplied by a multi-million-dollar catastrophic loss, L.
Then failing to have that human supervisor is legally negligent.
Exactly. The law is defining the duty of care for AI deployers. And the EU AI Act takes this even further. It classifies humanoids as high-risk systems, legally mandating a human in the loop.
Okay, I have to push back on this legal framework because, frankly, it sounds like a trap.
How so?
Well, if regulators force humans to monitor systems that operate at superhuman speeds, processing millions of data points a second, aren't they just setting up the human worker to be a legal scapegoat when things inevitably go wrong? Like, the machine makes a millisecond error, a part breaks, and the corporate lawyers just blame the human for not hitting the stop button fast enough.
You hit the nail on the head. That is the most pressing critique right now. There is a dangerous accountability gap between legal requirements and technical reality. The law mandates human presence, but ignores whether the human actually has the cognitive capacity to understand an AI black box decision in real time.
Which has to be incredibly stressful for the workers.
Oh, it is. It's having a profound hidden effect on the workforce. The psychological toll is massive.
Let's talk about that, because this isn't just about physical safety, it's about the psychological environment.
Exactly. Distrust of AI in manufacturing comes from three main things: surveillance and manipulation, threats to autonomy and dignity, and just total unpredictability.
So surveillance, we're talking about more than just a security camera in the corner.
Way more. We are talking about computer vision tracking, skeletal movements, wearables monitoring cycle times down to the millisecond. The OECD data is wild. 56% of manufacturing workers report increased pressure specifically due to AI data collection.
Over half the workforce feels pressured by algorithmic monitoring.
And 51% worry about privacy and algorithmic bias. They're terrified this granular data will be used to unfairly fire them or deny promotions.
And with high-profile data breaches, like, remember the Samsung ChatGPT leak?
Exactly. Samsung engineers accidentally leaked proprietary code just trying to use AI to work faster. Imagine if a factory's sensitive worker biometric data gets breached. It destroys trust entirely.
You know, it really is like working with a manager who just stands right over your shoulder with a stopwatch for 8 hours a day, recording every breath you take. It doesn't optimize your performance. It just induces a state of constant panic and eventual burnout.
And from a safety perspective, that burnout is lethal. Cognitive fatigue leads to tunnel vision. If you're mentally exhausted from being surveilled, you lose peripheral awareness, and that's when you step into the path of a moving robot.
The psychological stress literally causes the physical accidents.
Yes. Which is why complying with privacy laws like GDPR isn't just a legal checkbox. It's a fundamental safety requirement to foster trust and reduce cognitive load.
Okay, so we've mapped out the physical dangers, the legal traps, the psychological toll.
Mm.
We know the lights-out factory is a mirage. So what is the actual Industry 5.0 blueprint? How do managers balance AI efficiency with human oversight?
It starts with an engineering philosophy. Elon Musk actually formalized this after the Tesla disaster into a 5-step framework he calls the algorithm.
Right.
Step 1, question every requirement. Attach a real human name to it. Step 2, delete aggressively. If you aren't forced to add 10% back later, you didn't delete enough.
Okay.
Step 3, simplify. Step 4, accelerate. But step 5 is the absolute key. Automate last.
Automate last.
Right. Automating a broken process just scales waste. Get the human process right first.
So once you've done that, how do you legally and physically integrate the human?
The standard for this is ISO/IEC 42105. It formally defines the human oversight supervisor, a designated person with the authority to control the AI, and it outlines 3 specific modes of interaction.
Okay, walk us through the modes.
Mode 1 is human in the loop. This is the gatekeeper. The AI is completely blocked from acting until the human signs off.
So this is for the really high-risk stuff.
Exactly, like FDA batch releases or critical aerospace welds. The AI analyzes, but the human holds the key.
Got it. What's mode 2?
Human on the loop, the supervisor. Here, the AI acts autonomously, adjusting valves or writing parts, but the human is actively monitoring. If parameters drift or something unexpected happens, the human overrides it.
And mode 3?
Human out of the loop, bounded automation. This is just for repetitive, super low-risk data entry where the human just checks the logs later.
But wait, if you're in mode 2, on the loop, how do you stop the human from just getting lazy? Like, if the AI is right 99% of the time, the human is just going to start blindly trusting it, right?
That's called automation bias, and it's a huge risk. The solution is dynamic confidence thresholds.
What's that?
The AI is programmed to know its own uncertainty. If it's highly confident, it runs autonomously. But if its confidence drops below, say, 70%, it's hard-coded to halt and route the decision to the human.
So it asks for help.
Yes, and it has to explain its reasoning using tools like saliency maps.
Saliency maps, right.
It visually highlights on a screen the exact pixels or geometry that confused it. So the human isn't just staring at a prompt, they are acting as an active investigator. It completely breaks automation bias.
That is brilliant. Okay, so if I'm a factory manager listening to this right now, what is step 1 tomorrow morning?
Step 1 tomorrow morning is to halt any robotics purchases and start auditing your existing processes. Enforce the automate last mandate. Don't buy a single robot until you deeply understand the human workflows of your specific factory.
Perfect. So just to recap this incredible journey, we started with the illusion of the lights-out factory, saw the brutal reality of Tesla's production hell, uncovered the silent threat of model drift, and faced the physical and legal risks of kinetic automation.
And we laid out why the human supervisor is absolutely non-negotiable.
Exactly. True efficiency isn't about replacing human judgment. It's about elevating it with smart tools. But before we wrap up, you mentioned earlier there was one final provocative thought about intellectual property.
Oh, yes. This is fascinating. It's grounded in the new IE standards. So we've established that a human must intervene and guide an AI to prevent errors on the assembly line, right?
Right. They have to use their physical intuition to correct the algorithm.
So the question is, who owns the process optimizations that result from that? The I suggests that if a human is constantly guiding the AI, the human user should legally be considered the inventor.
Wait, really? So the factory worker on the floor could actually co-own the patent for the process they helped refine?
Potentially, yes. Could the factory workers of the future, rather than being replaced, actually become highly paid royalty earners for the manufacturing algorithms they physically oversee and correct?
Wow. That completely flips the entire economic narrative on its head. A blue-collar worker earning IP royalties from an AI. That is a wild thought to leave our listeners with.
It really changes the whole paradigm.
It absolutely does. Well, thank you so much for breaking all this down, and thank you, the listener, for joining us on this deep dive. We'll catch you next time on The Shifted Ledger.